Let me start with a scene that makes programmers break down at midnight. One big system, all the code crammed into a single blob, and you just want to change the color of one button. And what happens? The whole system, millions of lines, all redeployed. And then you wait, nerves on edge, for it to come back up. So people started breaking it apart. Take that one blob and split it into dozens, hundreds of small services, each doing its own thing, each deployed on its own. Sounds beautiful. But a new problem shows up immediately. So many services, scattered across a pile of machines, and their IP addresses keep changing. How on earth do they find each other? Today, we're taking this apart. What a microservice really is, and the key thing that lets them find each other. Service discovery. Same as always, I'll run it for real. I spin up a registry and a few services, kill one right in front of you, and see if the others can still find it. Look at this diagram first. On the left is the monolith. Every feature crammed into one process, one blob. On the right, microservices. The same features, split into little boxes, with lines connecting them, and those lines are the calls between them. The first step of the split, the primer puts it plainly. First, separate the web layer from the application layer. That way, you can scale them separately. Adding a new API? Just add application servers. You don't have to add web servers along with them. Split it further, and you get microservices. The definition of a microservice is just one line. A set of small, autonomous services working together. Each service holds to one iron rule. Single responsibility, it does one thing only. The upside is very concrete. Each team runs its own. The tech stack is free. One going down won't necessarily drag the rest down, and you can scale any single one on its own. But there's no such thing as a free split. You break one blob into a pile of boxes, and what used to be a single in-process function call between them is now, every time, a call across the network. That cost is going to bite you again and again. Following your gut, once you've split things, you might say? Easy, payments needs to call orders, so I just write the order's address into a config file. Done, right? You hit a wall. Orders isn't one machine. It's several instances doing load balancing. One of them dies, or you scale up and add two more, or you move it to another machine and the IP changes. That hard-coded address you wrote? Dead on the spot. Dozens of services hard-coding each other's addresses. Any one machine changes, and a whole swath crashes with it. Hard-coding, in the microservices world, is a dead end. You need something that lets a service check in on its own and lets others look it up dynamically. That something is called service registration and discovery. The primer names a few industrial-grade ones. Consul, etc. Zookeeper. The principle really isn't complicated. I'll hand-build one for you and run it right here. Just 3 actions. First, the moment a service starts, it checks in with the registry and records its own name and address. That's registration. Second, registering isn't the end of it. Every short interval, it has to send a heartbeat, telling the registry, I'm still alive. I call that renewing its lease. Third, when another service wants to use it, it asks the registry, where are all the ones called orders, and gets back a list of live addresses. That's discovery. Let's do it for real. I spin up 1 registry, 2 orders instances, and 1 payments. First, let the client discover orders.
The registry dutifully hands back 2 addresses, 196.01, 196.02. Both orders instances are there.
With those 2 addresses, the client can do load balancing on its own, calling them in rotation. Let's call 6 times and see.
6 calls, 3 per instance, evenly split. Note this. This load balancing is done by the client itself. No need to stand up another box in the middle. Just take the list of instances you discovered and round robin through it.
Now the key step. I'm going to kill one of the orders instances right now. The moment it dies, it stops sending heartbeats. Guess what the registry does?
Nobody has to tell it. Once that instance's heartbeat stops, Past the renewal deadline, the registry's background sweep finds it expired and drops it straight off the list. Query orders again, and only one is left, 9602. The dead one just disappeared on its own.
Look at the data structure behind this, simpler than you'd ever guess. Just one table, a name mapping to a list of address plus expiry time. A heartbeat just pushes the expiry time further out. A sweep just deletes the expired ones. The whole soul of service discovery is just this, a list that expires itself. Last step, service to service. Payments wants to call orders, but it has no idea where orders is. It asks the registry, gets a live address, and calls over. The whole way through, not a single hard-coded address. This is the key to why microservices can be loosely coupled. Splitting felt great, but you've got to do the math. The primer is honest about the cost of microservices. Let me lay it out for you. First, the network becomes a new failure surface. An in-process call almost never fails. A cross-service call can time out, can drop. That whole set from last episode. Timeouts, retries, health checks. All of it applies here, and it's a hard requirement.
Second, data consistency. Data is scattered across each service's own database, so the moment you want to change a batch of data across services, you slam into the hard bone of distributed transactions. Most of the time, the answer is eventual consistency, which loops us right back to the CAP episode. Don't reach for a distributed transaction at every turn.
Third, observability. One request passes through 5 or 6 services, and when something breaks, you have to lean on distributed tracing to stitch it back together segment by segment, far harder than debugging inside a monolith. So microservices aren't free freedom. They're development autonomy bought with operational complexity. So AI arrives. How does the application layer change? 4 questions, same as always. No hype, no bashing. First, what role does it play? In one line, the agent becomes the new service. A service used to be a stateless HTTP endpoint. Now an agent is also a callable unit, with its own capabilities and its own boundaries. Your system's service map now has a new kind of node, one that thinks. Second, what does it replace? This one is especially neat. Function calling and the MCP protocol are essentially the AI version of service discovery. Traditional service discovery is service name to address. Tools in MCP are capability description to a callable tool. An agent doesn't look up an IP. It looks up, who can help me do this thing? The dimension of discovery shifts from address to capability. MCP, plainly put, is service registration and discovery for agents. Third, what change does it bring? Between microservices, who calls whom first, how the parameters get assembled, what to do on error, that used to be glue orchestration code, hard-coded by humans, line by line. Now an agent can decide, based on the goal, which tools to call and in what order, all on its own. Orchestration goes from static code to a runtime decision. That huge blob of glue code is being eaten by the agent's self-orchestration.
But the underlying laws haven't changed. Nail this one down. An agent calling a tool still has to handle the tool being unavailable, the call timing out, the result being untrustworthy. That's the tool-level version of health checks and graceful degradation. New name, exact same work.
Fourth, what does it change? The granularity of a service gets pushed even finer. From a microservice down to a single tool call, a single function call. But the underlying laws, register, discover, health check, carry across all 3 generations. In-process functions, microservices remote calls, agents calling tools, same line. Break capabilities apart, then find a way to wire them back together. Who should watch out? The person who thinks that once you've got an agent, you don't have to worry about service governance. You've only moved service governance into tool governance. The high availability, timeouts, and degradation you owed are all still due, every one. 3 pitfalls. First, the registry itself is the single most critical piece of infrastructure here. It goes down, and every service goes instantly blind to the others. Nobody can find anybody. The whole site is paralyzed. That's why Consul, etcd, and the like are themselves held up by multiple replicas plus a consensus protocol. Loops back to CAP again. High availability is its lifeline.
Second, the heartbeat deadline is a trade-off. Set it short, and a dead instance gets dropped fast, but heartbeats fire often, and the network overhead climbs. Set it long, and you save traffic, but a dead instance may linger on the list for a while, and requests sent to it just fail. Fast or cheap, pick one.
Third, and the most important, microservices are not a silver bullet. A small team, a system that isn't complex, forced into microservices. What you get isn't freedom. It's a pile of avoidable network calls and operational burden. The monolith isn't that embarrassing. When to split is a judgment call, not an article of faith. Wrapping up. The one line I most want to leave you with today. The real hard part of microservices was never the splitting. Anyone can split. The hard part is, once you've split them, how do they cooperate again? Service discovery is what lets a bunch of independent services find each other loosely coupled and still withstand each other's failures. That's the glue that binds loose sand back into a single system. And AI pushes the granularity of a service all the way down to the agent and tool level, but the old laws of register, discover, tolerate faults haven't changed for a single day. Next episode, we drill into the hardest part of the data layer. A relational database whose data grows too big for one machine, whose reads and writes can't keep up? What do you do? Replication, sharding, federation, cut it one slice at a time. Same as always, I'll run it for you for real. I'm Ashley. See you next episode.